Hello everyone. Now let's discuss problem number 5 in this chapter, extended surfaces. Now look here what is given to us. A turbine blade made up of stainless steel with thermal conductivity 29, 60 mm length, 500 millimeter square cross sectional area, 120 mm perimeter. The temperature at the root of the blade is 480 and it is exposed through hot gases that are passing at 820. The heat transfer coefficient is 320. Now he's asking us to determine what is the temperature the middle of the blade, somewhere here, and he's asking us to determine the rate of heat flow. In order to do so, let's see the table and let's identify which case we need to consider. Now, definitely in the question, he has not given us that whether it is a long fin or a short fin or a fin with some temperature at the end. What we know is if I maintain the temperature at the end of the fin, probably that's going to be sort of adiabatic fin. But he's saying that the fin is not insulated. Okay, so in the sentence, it's definitely not a long fin. Then it has to be short fin with insulation, without insulation, or specified end temperature. Now, specific end temperature is not given to us of the tip. It has to be either a short fin with insulated tip or short fin without insulated tip. Now, if it is an insulated tip, it is adiabatic, and we don't have that condition in this case. Then it is definitely going to be short fin without insulation, insulated tip. Now, for the short fin, if I want to find temperature distribution in any part of the fin, this is the formula that I need to use. And if I want to find the rate of heat transfer, this is the formula I should use. Right now, if you look at these two formulae, or you can also use this one, there's no problem with this. So if you look at these two formulas, we have hyperbolic functions, we have m, we have l, we have k, and we have h, which is the convective heat transfer coefficient, right? And all the other variables which are given to us in the problem. So let's list all the variables that are given to us. So the length of the blade is 60 mm, which is 0.06 meter. The cross section area of the fin is given to us. The perimeter of the fin is given to us. The base temperature is given. The surrounding temperature is given. H is given and K is given. Let's find out what is M. So M, that's the first step. M is the root of H into P divided by K into A. If you plug in all the numbers from the given data, we get M around 51.46 meter inverse, right? And we know the formula now. I want to find, the first question is to find the temperature distribution in the middle, that is L by 2. So the length of the fin is known to me, that is 0.06. I want to find the temperature at X equal to 0.03. That's exactly half of the length. Now, the temperature T is something which I need to determine. This is the surrounding temperature, 820, that's given to me. The base temperature is given to me. The surrounding temperature is known. These are hyperbolic functions. M is known, and all the other factors here are known to me from the given data. If I plug in everything and solve, I'm going to get a temperature at about 745.54 degrees centigrade. That's the temperature in the middle of the fin. Now coming to the rate of heat transfer, that's the third step. So rate of heat transfer again is given by this formula. For this particular case, it's a short fin with end which is not insulated. Again, I know H, I know P, I know K, I know area, I know base temperature, infinite temperature, I know M, L, that's the total length we are going to take. I know H, I know M, I know K. So all the factors are given to me, all the parameters are given to me. Again, if I plug in all the numbers, I'm going to get Q as minus 253 watts. Now remember, that the negative sign indicates that the heat is flowing from the surface of the blade towards the root of the blade, right, towards the end of the blade, right? That's what the negative sign is indicating. So this is how we determine the 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 cases that we need to select um, for this particular type of problem. We have chosen case number 3 because it's a short fin with no insulation. I have no data that it is adiabatic in the end, or any specific temperature is given at the at the end. Remember that this 480 is the surrounding temperature, it's T infinity, right? It's not the temperature which is here. All right, so that was case number 5. We are left with case number 6, 7, and 8. Kindly go through those cases. These are identical problems through which we have solved. There is nothing more concepts to be discussed in this particular chapter. Thank you.